So, how does MRI actually work? At first, MRI sounds like impossible to understand, but let's break it down as a series of simple questions. Question 1. What is MRI looking at? MRI mainly looking at hydrogen nuclei inside the body. But why hydrogen? Because the human body contains a lot of water and fat, and both contain a lot of hydrogen. So if we can control and detect hydrogen nuclei, we can get a lot of information from the body. Question 2. Why do hydrogen nuclei matter? A hydrogen nucleus behaves a little bit like a tiny magnet. Normally, all of these tiny magnets point in the random direction. So even so, there are many of them, their effect mostly cancelled out. That means that we do not get a useful signal yet. Question 3. How does the MRI scanner organize them? This is where the main coil comes in. The main coil creates a strong magnetic field called the B0. When the body is placed inside a magnetic field, the hydrogen nuclei start to slightly align with the B0. Together, they form a net magnetization vector. We call it its vector M. If the hydrogen nuclei are aligned, why don't we already have an image? Because alignment alone is not enough. When the magnetization vector is just sitting along the B0, the scanner cannot detect a strong, useful signal from it. So, we need to disturb it. Question 5. How do we disturb it? We use radio frequency, or RF coil. The coil sends in short a burst of energy called the RF pulse. The pulse tips the magnetization vector away from B0 to a perpendicular direction. Question 6. What happens after the RF pulse? After the RF pulse, the magnetization vector is pushed into the transverse plane. Instead of just putting along the B0, it now rotates around the B0. This rotating motion is called precession, and this is the moment MRI gets its signal. Question 7. Where does the MRI signal come from? The signal mainly comes from the rotating transverse magnetization, or MXY. When MXY is large, the received signal is strong. When MXY is small, the received signal is weak. So, the RF pulse turns hidden longitudinal magnetization into a detectable transverse signal. Question 8. Why does the signal fade away? Because the hydrogen nuclei does not stay perfectly synchronized forever. Right after the RF pulse, many spins are rotating together, which makes their signal add up, but over time they gradually fall out of sync. As they lose of synchronization, the transverse magnetization becomes weaker, which is called the D2 decay. Question 9. What is T1 then? The T1 is the recovery of the longitudinal magnetization. After the RF pulse tips M away from the B0, the system slowly returns to its original state. The magnetization vectors also gradually recover back to B0, which is called the T1 recovery. Now here comes the question 10. Why are T1 and T2 important for MRI imaging? Because different tissue recover and decay at a different speed. Fat, fluid, muscle, tumor, edema, blood, and so on, they all have a different relaxation behavior. By changing the time of the RF pulse and signal readout, MRI can emphasize different tissue property. This is why we can create a T1 weighted, T2 weighted images, and many other types of MRI contrast. Question 11. If we can detect a signal, how do we know where it comes from? This is the job of the gradient coils. The body is full of the hydrogen nuclei. A signal could come from anywhere, so MRI needs a way to label position. Gradient echo creates small changes in the magnetic field across space. This means that hydrogen in a different location experiences a slightly different local magnetic field. And because the rotation frequency depends on the magnetic field strength, different locations produce slightly different signal pattern. This makes MRI encode spatial information. Question 12. Who listens to the signal? The receiver coil. The receiver coil detects the changing electromagnetic signal created by the rotating transverse magnetization. Then the computer processes the signal and reconstructs it into an image. So the simplest way to remember MRI is this. B0 lines things up, RF tips them over, MXY creates the signal, T2 makes the signal fade, T1 brings magnetization back, gradients encode position, and then the receive coil listens. And this is the basic principle behind MRI.